Right, this is number 6. We're going to start out with the numerical example that I have, and you can see that I'm just replacing now. The 10 and the 4 are in the same place. The 2 and the 2 over here, the 2 that's here is in the same place as the 100, and the half is the same place as the 2. So I just replace them one by one, and I get 4 to the half is 2. Look how easy it is with a good example. Same thing goes right here. If I want to look at 10 to the 5th, a log base 5 of 0.04 is equal to minus 2, I do my same replacement trick, and I get 5 to the negative 2 is 0.04. So here, I need more than just my example. I need log rules. So log of a times b is log of a plus log of b. And log of a to the r is r log a. Those are the two main ones I use. If it's a divide by, it would be a minus here. So I consider that the same rule. Mathematicians think of those as inverse functions, so I don't really write that down as a separate rule. This ln is natural log, and it's a special log. This is out of the scope of what we're talking about now, but it's log base e, where e is a number like pi, named after the mathematician Euler. And so this is really, this follows all the log rules. So how do we deal with this? Well, the first thing is that I'm going to apply this second log rule. I really have an r out in front. The r is 3. So I can put that inside the parentheses by raising the inside to the power 3. And so I get this thing right here. And now I'm going to use the first log rule. In this case, the a is 4 and the b is 3. Cubed, and they just multiply together, the product, and it turns out that that's natural log of 108. So just to take a look at what you have there, and let's go to the next one. These look more complicated. These are the kind of scary math they put on boards so that in movies to make you feel like you don't understand what you're doing. But they're just simple. You're following rules. So I put my numerical example up here, and I put my 2 log rules here, and I wrote down the problem, the first problem. So the first thing is that I can combine all these inside as one product. I'm going to use this first log rule. When I have a minus, it's a divide, and when I have a plus, it's a times, all inside the argument of the log base 3. If I do the math, I get the arithmetic, I get this thing right here. And I'm really looking for, keep having to move my face. So I'm really looking for what power of 3, I'm using my numerical example here. What power of 3, because the 3 is where the 10 is. What I'm missing is what's on the other side of the equal sign, the 2. So what do I put instead of the 2 to get this as my right side? Well, if I do the arithmetic, that's 27. And I play with numbers a lot, so I know that the answer in that question mark is cubed. 3 cubed is 27. So that's why this is a 3. If I go to the next problem, it's a similar thing. 140 divided by 50 divided by 70. So I went on a calculator, that's 0.04. I really want what power of goes up here, that's 0.04. Nothing makes me more annoyed if someone takes away my calculator. So you can actually just guess and test if you want. But I know this will be negative because it can't be positive because 5 squared is already 25. 5 to the minus 1 is 1/5, which is 0.2. 5 to the minus 2 is 0.04. So I know that this answer is -2.